Hi everyone, today we'll be doing some pandas practice and we'll really try to get you familiar with its various functionalities. We'll be using the election data set from lecture and you can see the first 10 rules over here. So let's dive right into problem one. Problem one is asking us to write a line of code which returns the elections table sorted in descending order by popular vote. So what does that really mean in terms of the data frame? So popular vote is a column in our elections data set, and our goal in problem one is to shuffle the rows around such that the numbers in the popular vote column are in descending order. So let's do that. For that, we'll start with the elections data frame, and we'll use a method called sort values. Just write that down. And we are sorting the values on the popular vote column. And if you run this, you'll see that the popular vote column is actually sorted in ascending order, while we want descending. So we'll need to specify that ascending needs to be false for sort values to give us ascending order. By default, sort values essentially gives you the ascending order. So that is the first part of the question. The second part of the question is asking us whether calling sorted.alloc on the 0th index will give you the same result as sorted.loc on the 0th index. So before I give you the answer, just pause the video for a moment and really think about, will it really give you the same result or not? But I'm going to go ahead and run this for you. And as you can see, these are different. The reason is that iloc is integer-based indexing. So it's essentially, it's taking the first row of the sorted data frame and returning that. And since Python, then Python is zero-based indexing, the 0 means the first row. In .loc, however, you get a completely different row. And that is because it's returning the first row of the initial data frame. And if you'll notice that row has the 0th index. So it's basically, the .loc is looking at the actual index labels that each row has. Okay, so that was problem one, moving to problem two. Using Boolean indexing, write one line of pandas code which returns a data frame that only contains election results from the 1900s. And if you look at the data frame, you'll notice that there are rows which belong to the period before 1900, and there are rows which belong to the period after 1900, it's in the 2000s. So we need two conditions. So the general structure of this query would be, first of all, write the data frame, and then we can write the two queries in these two parentheses. So here we'll be making references to the year column, because that's where the data about 1900 is present. So the first condition is that year column should be greater than or equal to 1900, and elections, the second condition is that the year column needs to be less than 2000. Now, again, as you can probably notice that there's multiple ways to write the same thing, but this gets the job done. And here you can see the rows are only between 1900 and 1996. So that was problem two. Moving to problem three. Here you have to write a line of code which returns a series where the index of the party and the values are how many times that party won the election. Now, as you can probably see from the data frame, that the data frame also contains a mix of wins and losses. However, that information itself is contained in the result column. So the first part of the code will try to only select those rows which are wins. So we'll essentially Boolean indexing again. Let's go to result and only select the rows which are wins. And after that, we'll try to return the series as required. So the first method is using value counts. Here, we'll select the party column and we'll do a dot value counts on that. And you'll see that this is just basically here each row is a party, and this is the number of times that party appears in that column. Second method is using group by. So here, again, we have the same condition that we are only looking at bins. And now, since we're changing the index and we want to find an aggregation number for each party, essentially we need to group by party. So here we group by party and we do dot size. Now dot size does the same thing as dot value counts the number of times that particular party came up in that column. The only difference, as you can probably see, is that this is not in descending order. But since that was not a requirement of the question, both methods work. Now, moving to problem 4. Write a line of pandas code that returns a series where the index of the years and whose values are the number of candidates that participated in those year selections. This is very similar to problem 3. And here, we can just do group by. So again, we start with the elections data set. And here, again, keep in mind that you have to change the index. Now the index needs to be the year. So we need to group by the year. And we can just do a dot value counts again and get the number of candidates. Okay. So here we need to just, I think all we need to do is, here we need to do dot size, sorry. Yes. The dot size will give you the number of times that particular index is present in the data frame. So essentially the number of rows in each group after the group by. And as you can imagine, you can do the same thing with value counts. So here is, just for the sake of completion, this is what you can do, value counts, and you get the same thing. As you'll probably notice, here the values are, here the series is sorted by the number of candidates that participated in those year's elections. For example, you can see the 1996-7, but essentially the content of the series is the same. So that was problem 4. Moving to problem 5. So problem 5 is a little more tricky than the others, but again, we'll get through it. So here you have to create this variable called filtered parties. And this filtered parties will be a version of the election data set where we'll only keep the parties that have won at least one election percentage, or that have at least one election percentage more than 50%. So essentially, we make a group for each party, and we see that whether at least one row has an election percentage more than 50%. So here, essentially, to create those groups, we need to group by party. And instead of using .size or .ag, we use .filter. And to write this condition down, we can just use a lambda function and use SF for subframe. And the condition is that the subframe percentage, the maximum of the subframe, so the percentage column in the subframe, needs to be at least 50. This will give you the required rows. So as you can, again, it's not clear here because you can see these 42, but again, the condition is that the Democratic Republican Party needs to have at least one election where they had more than 50% of the votes. And you can see that that's the case over here in the first row. Okay, so moving to problem 6. Problem 6 is asking us to use the filtered parties data frame and return a new data frame where the row indices are the year and the columns are parties. Now, before we move to the other parts, let's talk about what kind of data structure we might be looking at. So here, the rows are the years and the columns are the parties. Now, year and party, if you look at the original data frame, year and party are two different columns. And essentially, what we're trying to look at is the combination of the values of these two different columns. So, for example, 1824 and Democratic Republican is one combination. 1828 and Democratic is one combination. 1832 and Democratic is another combination. So that's what we're trying to look at. So actually we will filter parties, and we can do dot pivot table. And here the index needs to be the year, and the columns need to be the party. Now, what values does to go inside? And that's where the other part comes in handy. So here we're looking at the percentage of votes, and you're looking at the total percentage of votes. So, our values are percentage of votes. Now, if you notice, for example, in these first two rows, you have the same combination of year and party, but different percentage of votes. So we need a way to aggregate them because we only have one box to fill in for that party. So essentially we do ag func equals np.sum because we want the total percentage of votes in this case. And after that, essentially, we can just run this and see what we get. So if you notice, we get kind of the same result as the required output. However, instead of NANs, we have zeros. So NANs really point to, our NANs are missing values which are basically the cases where that party did not have a candidate in that year. So the pivot table actually gives us a really nice method attribute to fill in, which is fill value. So here, when we say fill value equals 0, you can essentially just substitute all the NANs to get 0 values. Okay, so that was all the problems for today. And yeah, I'll see you next week.